Good afternoon, everyone. Welcome to the panel from chips to qubits, the next industrial revolution, and the European strategic path and the role that Greece can play in sovereignty and in developing its own tech. I'm really excited to have excellent panelists with me, and without further ado, I will start by throwing in the first opening question. We're in the middle of a global technology race. We have semiconductors that define the technology and the industry of the 20th century, and we're moving to the next quantum revolution, which will be as bigger, maybe from steam engines to electricity, the quantum revolution. The European Chips Act is a clear signal. It's clear and it's signaling to all directions. We have to control over hardware. We have to develop materials and control the supply chains, and it's a strategic sovereignty challenge. The next frontier of quantum technologies is already here, and they go hand in hand together. Greece has been already acting in both fronts, especially at the National Center for Scientific Research, Democritos. We have a new quantum institute spearheading the efforts in quantum computing and quantum sensors, and there has been active research for decades in nanotechnology and materials through the Nano Institute. The questions today, and we'll try to answer as many as we can around that, is how do we move from technology and scientific basic research to real industrial impact? Where does Greece fit in this transition, and what is its role within the European ecosystem? I will try to start by placing the first question to Mr. Kritikos. I would like to give us your point of view of how Greece, you think, and Europe can really act actively and not stay outside the game.
So, thank you very much for the question. Greece's positioning within Europe should be seen in a realistic and forward-looking way. I would like firstly to stress out that it is not too late for Greece. As personally I have came to notice, other European countries, country members, are in a similar positioning. We have not fallen behind, and so that there is a clear opportunity for Greece to move fast and forward towards the new era in chips and quantum technology. Secondly, I would like to underline that we are operating in a fundamentally changed environment. Demand for semiconductors is accelerating extremely fast, driven by AI, data centers, and at the same time, semiconductors have moved to the center of geopolitical competition and have been part of trade wars. Finally, developments in the value chain, especially in critical raw materials, such as helium, gallium, etc., highlight how fragile and strategic the ecosystem has become. Who could imagine several decades ago, in the 70s, that the closure of the Strait of Hormuz could affect so significantly semiconductor production? In terms of Qatar is one of the biggest manufacturers of helium, and there is the closure of the Strait of Hormuz causes an immense disruption. So within this context, Greece is not aiming to cover the entire semiconductor value chain. Instead, our strategy is focused. It is actually being formed right now, and it is focused in strengthening our role in R&D and design, building on initiatives such as the Hellenic Chips Competence Center, contributing to Europe's resilience through critical materials. We are one of the main producers of gallium right now in Europe, if not the only one, and developing selected industrial and back-end activities leveraging cost competitiveness, talent. We have a lot of talent here in Greece, and our regional position in Southeastern Europe. Europe does not need every country to do everything. It needs each country to become essential in specific parts of the value chain. And for Greece, the objective is clear: to become a reliable and strategic contributor to a stronger and more resilient European semiconductor ecosystem.
Thank you, Secretary General Kritikos. This was extremely helpful, and it's great to hear that there is a Competence Center under development. We have already been we're not waiting for things to happen. I would like to continue with Mr. Terzis, and I'd like him to highlight from his perspective on innovation, where do you think Greece and Europe could really position itself?
Right, thank you. Let's first say a few words about the EU Chips Act so that we're all on the same page. So Europe has realized over the past few years that we need to expand our market share in global semiconductor production. And that initiative became the EU Chips Act with the objective of doubling the market share that we have as Europe in the entire world from less than 10% to 20%, which is an overambitious goal to be reached by 2030. Under this effort, there are numerous calls and funding for chips-related initiatives. The GSRI, the General Secretariat for Research and Innovation, has the honor to supervise the 11 top Greek research centers, including Dimitris, you mentioned earlier on. And through them, and through calls that we have been issuing over the past 5-6 years, we have allocated more than 20 million euros for research and implementation in chips initiatives. Now, with respect to innovation, I think we need, first of all, we have the talent, as Mr. Kritikos said. There is a demand in the global market, and I think this demand is going to expand due to market drivers like AI, and not just AI, like gaming and so on. So chips is a market that's expected to grow. Semiconductor market is expected to grow. And we are also starting to build an ecosystem, which is very important for driving innovation in any country. And in this, it's very important to, let's say, redirect funds or direct funds from the venture capital market in Greece towards chips-related initiatives. This is, I would say, a nascent market currently in Greece. And I think the state, plus the private sector, through venture capital and through other funding initiatives, should pay more attention. But there is a huge opportunity for the country, all the way to even attracting investment for building factories, semiconductor factories that are in the $1 billion or euro order or value. So that's how we drive innovation.
That's great to hear that. It's always good to, as they say, our Anglo-Saxon colleagues, to put your mouth where your pocket is. So
exactly.
That's definitely an important sign of real action. I would like to move to Secretary General of Telecommunications, and I'd like to ask him, from his perspective on telecommunication and his digital communication ministry, how does he see this new quantum revolution, and how does his perspective is so far about the upcoming things?
Thank you, Dimitris. Good afternoon to all. I mean, as my colleague said, in Greece we have talent. But in quantum, I mean, specifically, we have R&D. We have labs in Democritos, in Crete. We have people working in R&D in the National Technical University of Athens, in Kapodistrian University, all over Greece. So we have the talent. We export, actually, talent. Dimitris is an example that we try to import. So we have the industry. Industry is here. We have the association. So I think we have the ingredients. What we are missing is move from, let's say, ad hoc investments from the governmental side to a specific roadmap that will, of course, adjust. We will, of course, harmonize with the EU Act. So we need investments to flourish more these ecosystems. Now, in terms of telecom, we have already started investing. We have, apart from the kilometers of fiber, dedicated fiber for QKD, we are working also and want to invest more in post-quantum encryption, PQC, and we want to actually materialize all this technology to actual application. I think if we compare it with other technologies, I mean, we had AI, now AI has applications for the citizens, that's why it's all over. We had 4G moving to 5G. Everyone has now data, we're doing video conference with mobile phones, so we have the application, so we need the applications that will drive and showcase quantum, and this will be the driver for the market, and this will be actually the push for more investments towards the R&D and all the ecosystem, I mean, will have things and products to deliver. Thank you.
Thank you, Kostas. And I would like to jump a little bit to the other side of the room, to the head of the Research and Innovation Council, not, well, for any other reason. I ask my apologies to my two excellent co-panelists, but he has to be quantum in the next 20 minutes. He has to go to another room to chair another panel. So I would like to pass the baton to him and ask from his new position as the chair of the National Research Council, what is his expectations and what is his hopes for the next 5 to 10 years in both areas, quantum and chips?
Well, thank you very much, Dimitri, for giving me the opportunity to say a few things, because before I become a quantum panelist, I'm supposed to chair another panel in 20 minutes, 2 floors below here, and this has to happen. So, first of all, let me say that the European strategy for technological competitiveness has already defined quantum technology and quantum computing as a critical technology, along with biotech, along with space, along with AI. So quantum is already a buzzword everywhere in Europe, and what's expected from quantum is really huge. A disruption is seen to be coming, a disruption everywhere in all sorts of sectors, from banking to energy to drug discovery to space. It's all going to be disrupted, and it's all going to be accelerated. How are we getting ready for this thing coming up? In Greece, still the effort is modest. I'm very happy to have contributed for the establishment of the first Institute for Quantum Computing at Demokritos. I'm very happy that, Dimitri, you decided to leave Singapore and an incredibly, star career to come and help this institute take off. And it's incredibly important that already young people from the diaspora, young Greeks from the diaspora, are leaving their universities, and some of them are bringing also their startups along to come join the ecosystem in quantum. Once you get into quantum, things are I'm gonna move fast. In the National Council for Research, Technology and Innovation that I chair now, absolutely we do recognize and we do adopt and embrace the European policy, and so a very specific sectoral area of the National Council is devoted to critical technologies, including quantum. We strongly believe that Greece has incredibly good opportunities in what I would call quantum computing, even though I would agree with Dr. Karantzalos that the quantum communications is also quite a thing, and it creates a market already in this country, reluctantly though, but still it is creating a market. Quantum computing and quantum simulations, as I said before, with already incredible applications in drug discovery or in finance or in weather prediction, it is in general in complex phenomena and complex situations, complexities that cannot be dealt with conventional computers. It's going along fine. So it is a priority at the National Council for Research, Technology and Innovation. We do expect the Secretary Generals to help us with funding in Greece, but we start becoming successful in attracting funding from Europe. Now, I'm not the chairman of Democritos anymore, and with my new role at EY, I can really bring to the attention of everybody that even the private sector of Greece is changing. EY is investing in quantum, is investing in quantum consulting services to its clients here in Greece and globally. And one of the first things that I can share with you is that we have we're finishing up a study on the quantum readiness of the Greek economy. The results are not very encouraging. There's a long way to go, but things are moving, are changing. The transition from cybersecurity to post-quantum cryptography in the security domain, this is a big issue, and it's a big issue for defense as well. But the Greek corporations are very reluctant to invest today on something that doesn't have a clear mandate from regulatory bodies or from a government program. So Dr. Karantzalos and the other Secretary Generals, it is incredibly important that a national strategy is being devised and very soon in alliance with the European strategy, of course, in order to get things going and in order to get the private sector also involved in this revolution, as you said it. Otherwise, Greece and unfortunately the technological competitiveness of Greece will suffer. Things are going to go fast. You saw how fast things moved with AI. 5-6 years ago, there were not many sessions at Delphi about AI. There's not a buzzword this year, the quantum, but wait another 3 or 4 years and then we'll talk. And let me just close with the big project that the Greek government and the private sector are undertaking right now, and this is very important. This is the Gigafactory, the Giga AI factory. And in the heart of the Giga AI factory is quantum AI. And this is probably the most disruptive technology that we will encounter in the next few years. And it's very, very important that even in the initial planning, in the initial strategy of Greece, quantum AI, it is considered to be a priority.
Thank you, George. These are very good points. I'll distill 2 or 3, if I may. One, the need for a coherent national quantum strategy, twofold, both on the chips and on the quantum. B, the upcoming Gigafactory's participation, and hopefully, again, quantum will be a big part of that. So
that would be a huge success for Greece. If we win the Gigafactory, and you know that there are big investors in the private sector in Greece coming from abroad as well, research centers and universities, they are all working hard in this direction. This will be something much, much bigger, of course, than Pharos, the AI factory. And as I said before, quantum would be in the heart of this new program, this new establishment. I'm sorry to have monopolized so much my talk, but I have to leave in 3 minutes, unfortunately.
Let me jump into the next panelist. If there is some time, we'll take questions at the end.
One question just to understand. Is the objective to develop a quantum computer in Greece?
Okay,
no, I think I was clear about that.
Let me repeat the question because maybe without the mic, the camera. The question was whether we plan to develop a quantum computer in Greece.
No.
I can have a first go or Georgios can answer and then we'll go back to our panelists. No, we are not in a stage and we don't want that actually. Most of the South European countries, even Singapore that, was there for 20 years and we had spent $500 million Singapore dollars in innovation for quantum. We are adopting cloud access, and we are participating with friendly countries. This is a very important thing for sovereignty on the West to run machines. Developing a full-scale quantum computer is a very challenging task. It's a Manhattan project. It's at the level of CERN. However, the niche for us would be to have components, because quantum computers is not, it's a multi-component system, and the spearhead of the, in my opinion, the focus should be on application software, the algorithms, and complete applications. So let me go back to the other panelists, because I don't want them to feel left out. Good colleague, Director Gogolidis of the Nano Institute, I will pass the baton to him and bring the discussion back to the CHIPS Act and to the role that I would say the twofold role, software and algorithms and devices on the semiconductor level, especially within Dimitris, could play. And then I would like to continue with Mr. Zervakis on the industrial side of this.
Thank you very much, Dr. Angelakis. If I may say, we're all looking to quantum as the baby, okay, but the baby has a father, and the father is in his 30s, and that's the chips. So we're very happy that we have been in this field. Greece in the early 90s has made a serious policy about how to deal with microelectronics, at that time semiconductors. It has focused on design of circuits, huge efforts in Democritus, National Technical University, University of Patras, and other places. And it has also invested in 2 cleanroom facilities, one in Silicon, in Democritus, and one in 3.5 on Crete. This effort has now brought its fruit. We have a system, an ecosystem that is quite vibrant. It has excellence in research. It has many spin-offs, and it has several companies, not only in the HETiA that we will hear about in a while from Dr. Zervakis, but also in other areas, in space, in defense, in photonics. So yes, we are not losing the train. Thank you for Dr. Kritikos for this observation. But now we need, it's the time to go beyond this excellence and say we need to reshape the policy, what we can do to go to the next step of the CHIPS Act. And the CHIPS Act came because Europe has lost sovereignty. I will give you a simple example of what this loss means. In Greece, just before the crisis, there was a huge investment in photovoltaics in Greece, which was related to the chips. 2 silicon photovoltaic factories in Patras, 1 in Tripolis. A large investment. We lost all our graduates. They were hired in these factories. But the policy was not consistent within Europe. After a few years, they could not withstand the competition from China. So that was a total loss of sovereignty, not only for Greece, but also for the rest of Europe. So this is the time now to restart. And the ecosystem, both academic and industrial, has come together. A first step was the formation of an understanding. A second was to put together a few measures. And we have brought these measures as early as 2022 into the state. The measures were first to say that we are here once more, that we continue to be here. We proposed to the Greek government the formation of a new institute in Democritus. We call IMM, microengineering, microelectronics, microsystems. And this could be, just like the quantum, leading the efforts within Greece, uniting the 2 research centers, largest centers in Athens and on Crete. And the second effort would be to start modernizing our strategy, start working together with industry to see how we can, first of all, focus on a few things. We cannot do everything. Focus on photonics, focus on RF MEMS, focus on design, and together with the industry, say what do we need in order to go one step forward. We need some national investment, of course. We need some support. There is a plan that Democritus' 4th together with HETiA, have proposed on how we can move together. But also, we need a commitment from our politicians to understand that we are here. And not only we are here, but we want them and us to tell the world that we can have the infrastructure, we have the talent, we have actually a surplus of talent compared to the other countries of Europe, and therefore the country is a good place to invest. And not only in quantum, we are attracting talent, we are very happy that we are also attracting talent in chips. We have just elected a new professor coming from HETiA, it's 30 years old, to bring back a revitalization of the chips in Greece. So we can hear more about the strategy from Dr. Zervakis, I think.
Thank you, Vangeli. Maybe Dr. Zervakis can tell us on the industrial side and the industrial association.
Yes. First of all, I will focus on chips because, of course, quantum is the technology of the future, but the technology of today is chips. Actually, chips are the new oil of the economy since everywhere we have chips from space, defense, maritime, devices, data centers, chips are everywhere. Recent analysis showed that the semiconductor market will reach more than $1.5 trillion by the end of the decade, which is a huge number. In Europe, it is true that the last 20 or 30 years we didn't invest in semiconductor, and it was actually during COVID pandemic that we realized our dependency in the fabrication of the microchips coming from Far East, and Far East, of course, we mean Taiwan, China, Japan, Korea. But even though the COVID passed, we realized that we should do something. That's why we have the Chips Act in Europe. It is good that Greece, of course, is part of the CHIPS Act, and of course this is a great opportunity for us to attract more investments. Now in Greece, what happened is that the last 20 years the local ecosystem evolved. Actually, back in 2005, I believe that there are only 3 or 4 companies active in semiconductor in Greece. Nowadays, we have more than 30 companies, so it's a magnitude of order higher. And all this company is a mix of startups, SMEs, but actually we have a lot of multinational companies that acquired Greek companies, and now they have R&D centers in Greece, which is really important because we have all this great mix. All this ecosystem is focusing on services. They are developing EDA tools, they are designing chips, but for the time being, we don't have production. And this is exactly what we should plan to do. We are in direct collaboration with the Ministry of Development for drafting the strategy of Greece around semiconductor. This is actually a very significant milestone. Last year, we incorporated the Hellenic Chips Competence Center, which also was a major milestone, trying to facilitate this strategy and also to face what is the biggest challenge nowadays in the semiconductor, which is the talent. Although, okay, and at average we have good engineers, still in order to evolve even more, we need more. So we need to train them and upskill graduates towards semiconductors. And of course, what is really important now is that we bring production in Greece. This is really important. We are on the design services, okay, we are very good at that, we should invest even more on that, but really what is important nowadays is to bring production in Greece. And what we mean by production, we have 2 ways, either to have what we call the standard back-end facility for making test and assembly, or have a specialty foundry. There is no realistic scenario to have a foundry in Greece doing 3 nanometers cutting-edge technology for processors and memories, but it is realistic to have a niche application For instance, a niche application can be a biosensor or an optical component, and to have production here in Greece. Regardless if it is a niche or specialty foundry or it is a back-end facility, what is important is to associate this activity with a global Greek champion, to serve as a first user of this facility, to allow to make it sustainable. We have these champions in Greece, in defense sector, in maritime sector, in energy sector. So what is really important, and I want to stress it out, is that we should invest and give incentives from the government, following the national strategy, of course, to bring production in Greece.
Very good. Thank you so much, Mr. Zervakis. I think I would like to touch upon your last point about the end users, as I call them, and the connection between industry, research and innovation and talent. There are three levels, as I see it. You need talent, in this case, semiconductor engineers and quantum engineers. There's a big, actually already a shortage in quantum engineers globally and in Greece, software engineers and also hardware engineers. So that's a layer, and it would be great if we had somebody from the Ministry of Education, maybe next Delphi, there might be somebody from there as well. We'll try to invite. The talent development is very important, the innovation and the end user. Innovation should not be done just for the sake of research, there should be end users brought in. And on the last round maybe of closing, I would like to invite each of the panelists to highlight what they think is the most important. In my opinion, is a connection between innovation and end users. What would be the end users of Greece? What are the use cases that are relevant to the Greek ecosystem, both in terms of hardware, semiconductors, and in quantum? And add anything else that you might like. So,
catching up from your last comment, obviously we are very strong in naval manufacturing industries, very strong in pharmaceutical industries. So these are areas that we can find the end users that we need to support the ecosystem. But returning on how we are going to implement that, as was very clearly stated by Dr. Zervakis, we are currently forming our strategy. It is after having the Hellenic Chips Competence Center and after participating actively in the Semiconductor Board, we are now currently forming our strategy in cooperation with industry, because we have to bring industry closer to research. It is one of our main goals, because industry policy cannot be designed in isolation. Industry expertise is essential to make it effective. So beyond Greece, it was also mentioned that our effort is to make a European strategy more coherent. The scale of the issue is here. Currently, we are facing other powers such as China, that they are actually scaling at enormous levels. I've recently read, if I'm not mistaken, that BYD, the car manufacturing company, is preparing not a factory, an industrial complex. It's far beyond that. It's almost 130 square kilometers. It's as big as the region of HETiA. So you can understand that these are the players that we have to play with as Europe and as Greece. So I would like to make a comment, because it is very essential to speak about. I'm returning in the Greek aspect, and it is essential to speak about funding. We have engaged a conversation with HETiA, which are, again, the industry in Greece. We are very open as government to hear proposition because each industry has specific needs of funding. It's not the same for every industry. So we have to figure out what are the tools that are needed so that we can perhaps design them. Finally, and this is my motto, the challenge is not only to write down the strategy. The challenge, the actual challenge is to transform the strategy in factories, in renovation, in capacity building, and in investments in chips. So
to implement it, exactly. It's not theory, it's the experiment that counts, if I speak as an old physicist. Dr. Terzis, would you like to comment and
Yes. Picking up from where
Eleftherios
left. Yes, my colleague Eleftherios. So, right, I've been making some notes here beyond my prepared bullets. So, first of all, the semiconductor industry is raising as a policy factor in Greece. It's not that we don't know what to do with semiconductors, but we need to do more, we need to invest more, and we need to focus more on certain areas. Regarding applications, I think all areas of applications are open, maybe at a smaller scale, but I think given that we have the ingredients, that is talent and demand and funds, we could see applications in AI, in robotics, for example. Big robotics manufacturers like XAI, Elon Musk's Opus, Android, and so on. These guys want to bring billions of robots as personal assistants, humanoids, and so on across the globe. My personal vision is that they will not have the capacity, or my expectation is that they won't have the capacity to produce that amount of robots if demand exists there. So maybe we could invest in providing incentives to these big manufacturers, Chinese, American, or so on, to come and build the robots in Greece. So it's robotics, it's autonomous systems, and this includes self-driving cars. And we're actually having a proposal for a factory to be built in Greece. Some investors are looking at areas in Greece to build something like that, semi-autonomous at the start, and later on, fully autonomous. There is IoT, there is sensors, and we haven't mentioned defense a lot. So defense is a huge area of applications, dual-use technologies in general, but defense, given that we are a country that invests heavily in its defense. So in defense, we have trusted hardware, we have secure communications, we have Internet of Things, we have satellites, where your ministry is doing a lot, or micro satellites. And in general, I think all the applications that we see at scale in foreign countries, in big players like China, the US, maybe some countries in Europe are also valid for Greece at a smaller scale, but at an existing rate. We can be players here, and okay, I will disagree that we cannot build a factory. We have discussed that in another occasion. I think we can even draw investment to build a foundry, a factory, a big factory, in the order of a few billion euros in this country, eventually. So currently we are focusing on attracting R&D facilities, maybe testing, maybe packaging, but there is the opportunity to also expand to more than that once we establish the foundation. So the state, the Ministry of Development, and other ministries are working towards, let's say, expanding our semiconductor policy. Thank you.
Thank you, Dr. Terzis. And to rewind and bring back the discussion a little bit of quantum as well, and I like the more aggressive, the more ambitious tone that you put in, Dr. Terzis. Earlier, we have to go for the big thing.
I really believe that, yes. It's not a matter of just an exaggeration. I really believe that. I've been pushing for this for years now. I think we can
believe that too. That's why I'm here, and I left as other more fertile grounds for my home country, is we have to go aggressively. And if I talk a little bit about defense as well, it's extremely important to be sovereign. Quantum security, quantum algorithms, quantum computing is evolving so fast the latest development brought the time for breaking codes from 7 to 8 years to maybe 3, 4 years. And I would like to comment that quantum should be seen as a technology of now. It's not following semiconductors, it's hand to hand. So we have to go aggressively there. And I would like to pass the baton to Dr. Karantzalos to say a little bit of few things, because his ministry, we have to acknowledge, was one of the early ones to act on quantum, and we'd like to thank him for his support. Of course, the Innovation Ministry started the Institute, but there's some work on quantum cryptography and communications and some plans for computing. So, Dr. Karantzalos.
Yeah, actually collaborating in every investment in all fronts. So,
Yeah, that's great.
I'm an engineer, so usually I'm depicting problems and trying to find solutions. So we can do everything, but we have to change how the governmental side is operating and how we are procuring things. We are designing today, procuring tomorrow, next year, and we have the deliverable after 4 years, the technology is obsolete. This is what is happening. So we have to be really flexible, not going in direct negotiations. We will find a way, but we have to be really fast. The technology is moving so fast, so we have to be fast in asking the industry. We have to discuss with the industry. Industry is doing, and the industry delivers. So we have to go hand by hand, see with the roadmap that we discussed, in a transparent manner, say that we want to reach these milestones, have the funding, and with the industry, shape it, and have the ecosystem flourish more effectively. And of course, I think from the industry side, also they have to see also not the government as the main, let's say, source of funding. Of course, we will be the anchor customer, but they have to see also the other markets.
Thank you so much, Dr. Karantzalos. And if in the last couple of minutes, based on your last comment on the very importance of getting end users from the industry when you shape government policy, a country does well when it can get its three main stakeholders, academia, industry, and policymakers, communicating at the direct, no constraint, open channels like today. So I'm extremely happy that we managed to set up this panel today and get you all up here in Delphi. And I would like to have a last comment from the industry, which we hope in quantum to follow and form very soon. There are, the last time I checked, around 10 quantum computing companies in Greece, very small startups, some in sensing and some in communications, and 4 or 5 in computing. So what would be your...
So first of all, let me say that because we are talking about quantum and chips, that these are not competing technologies. Quantum computers will not replace the standard computers. We are talking about two technologies that should collaborate in hybrid models. So it's not that one is replacing the other. Actually, they are going to solve different problems. It's true that quantum is coming. It's true that they solve problems beyond imagination. But for the time being, chips is the core technology that drives all the world. And definitely, from the government, we need to see the incentives. It is in regulations, it can be fiscal, it can be financial, but definitely we are talking about private investments. It's not that the public money will give the boost to semiconductor in Greece, but definitely it will be the enabler to speed up things. And actually, we should take initiatives to bring foreign investments in Greece in the semiconductor area.
Thank you so much. Thanks. As a final line, if any of you want to understand and see how you can play a role in these two revolutions, quantums and semiconductors, especially if you're from the industrial side, this is the place to discuss. Please follow up here and ask us and talk to us. I would like to thank the panelists again, all our Secretary Generals, Dr. Gogolidis, Dr. Zervakis, and thank you all for coming and listening to us.